All right, we are starting chapter 6 with section 6.1, the nth roots and rational exponents. So starting with this core concept, we have real nth roots of a. So let n be an integer where n is greater than 1, and let a be any real number. If n is an even integer and a is greater than 0, you have no real nth roots. If a is equal to 0, and then you have one real nth root, and that is the nth root of 0, which is 0. If a is greater than 0, then you will have two real nth roots, which is going to be plus or minus the nth root of a, and we're actually not going to write it like this, but it's plus or minus a to the 1 over n. We're using this right here, plus or minus the nth root of a. All right, so then if n is an odd integer and a is less than 0, you will have one real nth root, which is the nth root of a. If a is equal to 0, one real nth root, which is the nth root of 0, or 0. If a is greater than 0, you will have one real nth root, which is the nth root of a. So, I know that's a lot of letters and everything, and it might be a little bit confusing to look at it as it is, but as we put numbers into these formulas, it'll start to make a little bit more sense. So let's go ahead and get to example 1. So example 1 says find the indicated real nth roots of a, root or roots of a. Our n is 3, our a is negative 216. So first of all, is n even or odd? Well, n is 3, so n is odd. And then a is, well, instead of writing is, let me use the symbol. A is negative 216, so a is less than 0. So looking back to the previous slide, what we wrote down, if n is odd and a is less than 0, then we are going to use the nth root of a. Well, all we're going to do is take n and a and plug them into this. So that means we're going to have the cube root of negative 216. From that point right there, all you are going to do is put that in your calculator. So if we look here at our calculator, we're just going to go to the calculation screen, and we are going to go to Control and use the little rooftop because it shows in blue there nth root of a. Well, our n is 3, arrow over, and now we can put in our negative 216 and press enter. Our answer there is negative 6, so our answer right here is negative 6. Okay, let's try another one. This one, we have n is 4, a is 81. Well, n is odd or even. Looking at 4, 4 is even. And a, 81, is greater than 0. So if we look back to that first page of things that you wrote down, when you're looking at the left side where n is an even integer and a is greater than 0, then we have plus or minus the nth root of a. So now let's just plug in our numbers. We have plus or minus the fourth root of 81. So once again, plug that in your calculator. So we have Control, the little rooftop. We're going to put a 4 right there. We're going to arrow over, and we're going to put an 81 right there. Press enter, and we get 3. So we didn't put the plus or minus in the calculator, and you're not going to, but make sure you write that down, plus or minus, and then you have your 3. So plus or minus 3 is our answer. Okay. Those are some extra problems. I'm not going to go through those. But now let's look at rational exponents. Let a to the 1 over n be an nth root of a, and let m be a positive integer. So if I have, and we're just changing the format of things here, if I have something written like a to the m over n, then I can rewrite that as the nth root of a to the m power. So look carefully. You see we have m over n. The n that's on the bottom goes out front. Then the m that's on the top of the fraction goes to the exponent. So the value on the top of the fraction goes to the exponent. The value on the bottom of the fraction goes in front of the radical. So here, if I have a to the negative m over n, the negative brings everything to the bottom of a fraction. Same token there, if I have the n on the bottom of that fraction on the exponent, it goes to the front of the radical, and the m on the top of the fraction goes to the exponent, but the whole thing is still in the big fraction because originally I had a negative right there in my exponent. So that's just using your exponent rules. And then there's a little thing out here that says a cannot equal 0. So if I have a to the negative m over n, it changes to 1 over a to the m over n, which ultimately will change to 1 over the nth root of a to the m power. All right, again, a bunch of letters. Let's put some numbers into it. We're just going to rewrite this, and it says evaluate each expression. Well, first, and could you put this in your calculator? Yes, you could, but what we are going to do first is we are going to rewrite this using the slide that was on the previous page. So using that slide, we have 16 to the 3 over 2. Well, the 16 is going to go under the radical, and then the 2 is on the bottom of the fraction, so it goes out front. In parentheses, the 3 is on the top of the fraction, so it goes out here. So now, what is the square root of 16? Well, the square root of 16 is 4, and then I have 4 cubed. What is 4 cubed? If you don't know right off the bat what 4 cubed is, you can use your calculator for that, and it is 64. The main thing you need to remember here is when I'm grading this, I will be going through to look for each of these steps. All of the steps will be part of the grade as well because it's showing how you convert. It's not all about just putting this in the calculator on these. So let's look at B, 32 to the negative 3 over 5. Well, if I have a negative in my exponent, I'm going to convert this to a fraction. So I have 1 over 32 to the 3 over 5 power. So then I'm going to have, and just to space it out a little bit, I'll use a bigger fraction. 1 over 32 is going to go underneath my radical. The number on the bottom of the fraction, the 5, will go in front of my radical. And then the 3 on top of the fraction will go outside the parentheses as the exponent. So again, you're going to go ahead and take the 5th root of 32. If you don't know the 5th root of 32, then you can use your calculator for that step. And it is, in fact, 2. So now we have 1 over 2 cubed. If you don't know 2 cubed, you can use your calculator for that. But 2 cubed is 8, so we have 1 over 8. Do not write a decimal for this. So if you were to put that in the calculator to begin with, it's very possible you would get a decimal answer. Do not write a decimal for this. You must have the fractional answer, as well as all of the work that goes with it. Right, moving on to example 3. You'll like example 3 because it says evaluate each expression using a calculator. Round your answer to 2 decimal places. So make sure you do that. Make sure you do 2 decimal places on these. Specifically says 2 decimal places. Do that. If it does not specify using a calculator and putting 2 decimal places, then you must use a fraction. Okay, so here, 9 to the 1/5. You're using your calculator. 9. Use a little rooftop. 1 divided by 5 in the exponent. That's 9 to the 1/5. Press enter. There's my decimal. And it says 2 decimal places. So I have 1.551. The 1 will not change the 5 at all. So my answer there is 1.55. And there you go. All right, look at the next one. 12 to the 3/8. So let's put that in there. 12. Use the rooftop. 3 divided by 8. Enter. 2.539. It said 2 decimal places, so that would be 2.53, but the 9 right there will round the 3 up to a 4. So 2.54. So my answer here is 2.54. If you do not round this correctly, you will get it wrong. All you're having to do is put it in the calculator and round. So if you can't do it correctly and round correctly, it will be wrong. Right here, this one's set up a little differently. It still says use a calculator. The 4th root of 7, all to the 3rd power. So we're going to open parentheses, get our nth root of a, so 4th root of 7. And on the outside, we're to the 3rd power. Oh, I didn't put that rooftop up there. Rooftop, then the 3rd power, and press enter. So we have 4.30, and then the 3 doesn't change the 0, so 4.30. Now, do you have to write the 0? Yes, you do. 4.30. It says 2 decimal places. Even if it's a 0, I want to see it. Okay? Make sure you're rounding correctly. All right. We'll look at a couple more without a calculator. So let's look at this first one, number 5, 4 to the 5/2. And it specifically says without using a calculator. So we're just rearranging. Remember, the bottom of the fraction goes out front. So we have the square root of 4. Put that in parentheses. And that's to the 5th power because the 5th is on top of the fraction. So what's the square root of 4? Well, that is 2. And then we have 2 to the 5th power. If you need to put 2 to the 5th power in the calculator to find that out, you may do so. And when you do, you're going to find out that that's 32. Let's do one more that's a fraction. So we're going to do number 6, 9 to the -1/2. The first thing you're going to do is make it a fraction. 1/9 to the +1/2. Okay, then we're going to change the format of this. So 1/, the 9 goes under the radical, the 2 goes out front, and the 1 on top of the fraction is the new power. I ran out of room here because of the fraction, so I'm going to move over to the next side. You would continue working down your page. And so I have 1/, the square root of 9 is 3, and that's 3 to the 1st power. So that is 1/3. Okay. I'm not going to do any more with a calculator because I feel like you can plug those into your calculator perfectly fine. If you need help with that, please let me know. All right, so now let's use those skills to solve this. It says find the real solution or solutions of 4x to the 5th equals 128. Well, the first thing that we need to do to solve that is to divide by the 4 and get that out of the way. So let's divide both sides by 4. Cancel our 4's on the left, and we get x to the 5th is equal to 32. So then to get rid of the fifth power, we're going to take the fifth root. So we have the fifth root of x to the fifth. And if we do that to the left side, we have to do it to the right side. So the fifth root of 32. On the left side, the fifth power and the fifth root cancel and leave me with x. On the right side, I'm finding the fifth root of 32. You're welcome to put that in your calculator if you would like. When you do, you're going to come out with 2. So there, x equals 2. Okay, let's do another one. This one is in parentheses, x minus 3 to the fourth power equals 21. Well, the fourth power is on the outside of the parentheses, so I have to take care of it first. So I have a fourth root of x minus 3 to the fourth power. And then on the right side, I have the fourth root of 21. So on the left side, the fourth power and the fourth root cancel each other out, leave me with x minus 3. Now, if I take the fourth root of 21, I'm going to get a decimal. So for right now, I'm just going to write this down, but it is an even power and an even root. So going back to the very first slide of the notes, we have to put a plus or minus anytime there's an even root. So plus or minus the fourth root of 21. For now, we're just going to leave it just like that. Now, add 3 to both sides of the equation. On the left, they cancel, and we get x equals 3 plus or minus the fourth root of 21. Don't forget to write that little 4 up there. Since it is plus or minus, I would like for you to write them separately. So we have x equals 3 plus the fourth root of 21. And then we have x equals 3 minus the fourth root of 21. So from here, you can put that in your calculator because it does not come out correctly. I say correctly, it does not come out evenly as an even root. So we can put in 3 plus the fourth root of 21. And when we do that, we get 5.14. So x equals 5.14. The other one is 3 minus the fourth root of 21. So let's try that. 3 minus the fourth root. It didn't work. There we go. Fourth root of 21. Enter. And I get 0.859. Well, if I'm rounding to the nearest tenth, to the nearest hundredth, the second decimal place, that 9 is going to bump the 5 to a 6. So it's going to be 0.86. So x equals 0.86. And those are my 2 answers for that one. Okay, that's all of 6.1.